All right, y'all, welcome to 6.8 today. We are going to learn about angle measures, standard angles, reference angles, and coterminal angles in radians. So go ahead and help me fix this typo for you. We're going to learn about this in radians. Okay, you will want your paper copy of the unit circle for this lesson. We're going to label the other side of it, so give yourself a minute to find that if you need to. When we talked about radians a few lessons ago, we talked about them in terms of a different mode in the calculator. And a radian is a different measure unit for angle measures. Like a pencil can be measured in inches or centimeters. An angle measure can be measured in degrees, which is what you're used to, or radians, which is what we're learning more about today. Okay, a radian is based on the circumference of a circle. So pi is often used in radian measures. And on all the measurements that are on the unit circle, we will be using pi. So this is what a radian amounts to. We take the length of the radius and we lay it around the edge of the circle. The angle that creates is 1 radian. So if we consider how many lengths of the radius are all the way around the edge of a circle, that amounts to the circle's circumference. So the circumference of a circle is 2 pi r. Now, that 2 pi r all the way around a circle represents the 360 degrees all the way around a circle. So what we can do is divide that by 2, and pi radians is 360 divided by 2, or 180 degrees. And this is the conversion degrees to radians. Pi radians is equal to 180 degrees. So we are going to use that to label the angles in radians on the unit circle. So we're going to use this axis here right now, and then we'll switch to the big circle in just a minute. 0 is still on the right, and it's 0 radians. It does not have a degree symbol on it. Okay? We just determined that pi radians is 180 degrees. 180 degrees is on the left, so pi is on the left. Now, we need to go halfway between that. Between 0 and pi, halfway is half of pi. We call that pi over 2. So we have pi over 2, and then we have pi. On the bottom, we would need 1.5 pi's. Mixed numbers don't go, so we call that 3 pi over 2. And then back around to the end, back around to the beginning where we started, that is 2 pi radians. Think circumference of a circle. 2 pi r is 2 pi radians. These are the axis of a unit circle when we are in radians. Now, let's go to our unit circle and let's label some more on it. We did degrees, okay? Backside is blank. It's for radians. So here, we're going to label this side in radians. Okay, now, same as what we just determined. 0 is on the right. Pi is on the left. Pi over 2 is up. 3 pi over 2 is down. And 0 wraps back around to 2 pi radians. Now, similar to before, okay, all of those measurements were on the axis. All of those measurements were on an axis. We're going to do the same thing. We're going to divide the axis into its pieces. Okay, so if we look at what the halfways are going to be, halfway in a quadrant, we learned was 45 degrees. Well, we're not in degrees, we're in radians. In radians, that is halfway between 0 and 2 pi. Well, that pi over 2, I'm sorry, halfway between 0 and pi over 2. Well, half of half is a fourth. Half of half is a fourth. So this first spoke is pi over 4. And each spoke after that is going to be counted by pi over 4. So here's what we mean. Okay, we start with pi over 4. The next one would be 2 pi over 4. Then 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. We're counting around by pi over 4. Now, a couple of these will reduce. 2 pi over 4 reduces to pi over 2. 4 pi over 4 reduces to just pi. 6 pi over 4 is 3 pi over 2. And 8 pi over 4 is 2 pi. So those measures on the axis will reduce. So counting around the circle, we do start with 0. The axes are included. Pi over 4. The next was equivalent to 2 pi over 4, which, yes, is pi over 2. The next halfway will be 3 pi over 4. And then on the axis on the left, that's 4 pi over 4, which is equivalent to just pi. In the bottom half of the circle, halfway, we have 5 pi over 4. And then we have 6 pi over 4, which reduces. Then we have 7 pi over 4. And then we have 8 pi over 4, which reduces. So these are the halfway measurements in each quadrant. The halfway measurements are counted by pi over 4. Now, a quick word about these fractions. We are going to leave these fractions as improper fractions. Do not make a mixed number out of these. Leave these in the form they're written here. Now, we do have another set of angles we need to label, and those are the ones that were a third of the way through the quadrant. So counting the axis, including the axis, and a third of the way through each quadrant. So look at from 0 to 2 pi. Pi over 2, I keep doing that. From 0 to pi over 2. If we take half of pi and cut it into thirds, each of those pieces is 1/6, 1 over 6. So this first spoke and all the spokes that represent 1/3 of a quadrant are going to be counted by pi over 6. Okay, and we'll do the same thing. We'll count by pi over 6, and we'll reduce as we go. So 0, 1 pi over 6. The next would be 2 pi over 6, which becomes pi over 3. Next would be 3 pi over 6, or pi over 2. Then 4 pi over 6, which is 2 pi over 3. Then 5 pi over 6, and 6 pi over 6, which is just pi. So the axis and every other spoke is going to be able to reduce. Now, let's go to the bottom. We were at 6 pi over 6. Let me get all the colors on here. We start with 6 pi over 6, which reduced to pi. The next would be 7 pi over 6. Next would be 8 pi over 6, which is 4 pi over 3. Next is 9 pi over 6, which is 3 pi over 2. Then we have 10 pi over 6, which is 5 pi over 3. Then we have 11 pi over 6. And back at the start, we're at 12 pi over 6. So these numbers in red that are closest to the circle are the radian measures we need for the angles 1/3 of the way through each quadrant. Now, let's use these angles. Let's use what we just learned about radians. And let's do some standard angles and reference angles. Okay? Just like in degrees, a standard angle, the initial side is on the positive x-axis, that's at 0. The vertex is at the origin, that is still 0, 0. Positive angles are measured counterclock. Negative angles are measured clockwise. It's the same thing as standard angles in degrees. Reference angles are also the same as they are in degrees. It's a positive, acute, or right angle formed by the x-axis and the terminal side. And there should be a period there. So, given all of this, we can find angles, find their standard position, and find their reference angles. And I'm going to show you a way to do that in radians. It's going to make things pretty simple. Okay, so let's look at example 1. And we want to locate 3 pi over 4 in radians. So here's what I do in radians. Start on the right with 0. That won't change. The left is pi. Now, our denominator in this fraction is 4. So I'm going to label this left side as 4 pi over 4. And that's going to help me count this circle, count these axes in terms of pi over 4. So halfway between 0 and 4 pi over 4 would be 2 pi over 4. Then there was 4 pi over 4, counting up by 2 pi's would be 6 pi over 4, and 0 would be equivalent to 8 pi over 4. Remember, 8 pi over 4 reduces to 2 pi. 0 and 2 pi are in the same position. So the angle we were needing to find is 3 pi over 4. Well, 3 pi over 4 is going to be halfway between 2 pi over 4 and 4 pi over 4. The initial side is at 0, positive x-axis. The terminal side will be in quadrant 2, halfway between. And this is where 3 pi over 4 is going to fall. So this is in quadrant 2. Now, let's do this again with example 2. We want to locate negative 2 pi over 3. So that's this being a negative angle. We're going to do the same thing we would do with a negative angle in degrees. We're going to number this axis what feels backwards. So starting on the right is going to be 0. The left is equivalent to pi. Because this denominator is a 3, I'm going to label this as 3 pi over 3, and it's going to be negative. Now, 3 pi over 3, halfway between 0 and 3 pi over 3, is going to be 1.5, 1.5 pi over 3. Now, and it's going to be negative because we're going clockwise. You're looking at that 1.5 over 3, and you're thinking you can't mix a decimal and a fraction. And you really shouldn't in a final answer. However, for purposes of finding angles on the unit circle, we can mix the decimals and the fractions. It will be fine. So what this tells us is that from 0 down is negative 1.5 pi over 3. So then 3 pi over 3, another 1.5 would be 4.5 over 3, and it will still be negative. Add another 1.5 to that numerator, and we get 6 pi over 3, which really is 2 pi. So this is how we number the unit circle in radians. It's okay to mix those decimals and fractions. Now, we wanted the angle negative 2 pi over 3. We start at 0. Negative 2 is going to be between negative 1.5 and negative 3. It's a little closer to negative 1.5. So here is our negative 2 pi over 3. And this is in quadrant 3. Quick reminder, this negative angle rotated clockwise, while the positive angle we did first rotated counterclock. Now, just like in degrees, there are coterminal angles. Coterminal angles terminate or end in the same position, the same place, and that may be stated as the terminal rays coinciding. The angles coincide. That means they're at the same place. Now, coterminal angles will differ by the entire measurement of the circle. So in radians, that is 2 pi. So to find a coterminal angle, we add or subtract 2 pi. Now, we are going to add and subtract with fractions, okay? So we may not always need 2 pi. We may need a different form of 2 pi. So depending on our denominator, we may need to convert that, okay? If we have no denominator, we'll use 2 pi. But if we have a denominator of 2, that's going to be 4 pi over 2. If we have a denominator of 3, that's equivalent to 6 pi over 3. If we have a denominator of 4, it will be 8 pi over 4. And if we have a denominator of 6, that will be 12 pi over 6. All of those are equivalent forms of 2 pi. We may need to use any one of those. If you're looking at that and going, Miss Seifert, you skipped a denominator of 5. I did, and there's a reason for that. And that's because the denominator of 5 does not fit one of the special right triangle angles that we have on our unit circle. And the angles on our unit circle will be our big focus. So let's look at some examples. Let's look at example 3. We want to find the coterminal angle in standard position that's between 0 and 2 pi radians. And we're looking for its quadrant. So we want to label the axis in radians and then place our angle there. One of the first things you want to look at is look at the fraction and see if it's more or less than 2. If it's more than 2, that's like being more than 360 degrees, and we need to convert it. So 7 pi over 6, 7 over 6 is a little more than 1, but it's less than 2. So we can fit this angle on the unit circle. 0 is on the right. Pi is on the left. I'm going to label that as 6 pi over 6 because that's the denominator that we have. So then half of 6 is 3, which will be up top, 3 pi over 6. Then counting around 0 to 3 to 6 to 9 pi over 6. And then this 0 would be equivalent to 12 pi over 6. Once you get the halfway that's up, you know what numerator you're counting by all the way around the circle. And as far as labeling the unit circle, don't feel like you have to reduce that fraction. It's actually going to be easier if you don't. So we're looking for where 7 pi over 6 falls. 7 pi over 6 is between 6 pi over 6 and 9 pi over 6. So this is in quadrant 3. And we can draw our angle. The initial side will start at 0. 7 pi over 6 is a little closer to 6 pi over 6 than 9 pi over 6. So 7 pi over 6 falls here. Okay, that coterminal angle, we didn't need to convert. So that coterminal angle is 7 pi over 6 because it was already between 0 and 2 pi. Now, let's talk about B. B is a negative angle. So already we know that it's not between 0 and 2 pi radians. So what we need to do is add or subtract 2 pi. Now, we have a denominator of 4. So we're going to use that to help us. 2 pi, we need to add, but we need a denominator of 4 to add fractions nicely. So the equivalent of 2 pi with a denominator of 4 is 8. Yes, we just doubled that denominator. 8 pi over 4 reduces to 2. So as we are planning this angle, negative pi over 4 plus 8 pi over 4 is 7 pi over 4. So 7 pi over 4, 7 over 4 is less than 2, so it will fit on the circle. We want to number this circle in terms of pi over 4. 0 is always on the right. On the left is always pi. I'm going to label that 4 pi over 4. Halfway would be 2 pi over 4. So we're going to count around the axis. 2 pi over 4, 4 pi over 4, 6 pi over, that's a 4, and around to 8 pi over 4, which is again equivalent to 2 pi. That's an equal, not a negative. Okay, so 7 pi over 4 is between 6 pi over 4 and 8 pi over 4. So we'll start at 0 and we'll rotate around to halfway between in quadrant 4. And this is where 7 pi over 4 is located. So 7 pi over 4 is in quadrant 4. Now, let's look at C. 8 pi over 3. Looking at that 8 over 3 fraction, and it is bigger than 2. 6 over 3 would be equal to 2, so 8 over 3 is bigger than that. So the first thing we want to do is get that into the range between 0 and 2 pi. We want to subtract 2 pi. Needs a denominator of 3, so that needs to be 6 pi over 3, because that's what reduces to 2 pi. So 8 pi over 3 minus 6 pi over 3 is going to give us 2 pi over 3. So 2 pi over 3 is actually the coterminal angle. Now, to find it, to locate it, number the axis based on pi over 3. 0 is on the right, pi is on the left. I'm going to call it 3 pi over 3. Half of that is 1.5 pi over 3, which feels weird, but it's okay. So we count around by 1.5 in the numerator, 1.5 to 3 to 4.5 pi over 3. and then around to 6 pi over 3, which is equivalent to 2 pi. Then to locate 2 pi over 3, it's going to be between 1.5 pi over 3 and 3 pi over 3. It's going to be closer to the 1.5. We start at 0, and we rotate a little bit into quadrant 2, and 2 pi over 3 is located here in quadrant 2. Now, let's look at D. Negative 13 pi over 4. That's a negative angle. It's automatically not between 0 and 2 pi, so we need to make it fit. So what we'll need to do is add 2 pi. Well, we have a denominator of 4, so adding 2 pi is going to look like adding 8 pi over 4. When we add 8 pi over 4, we get negative 5 pi over 4. Now, we can fit that on our unit circle if we number it backwards. So we can graph it from here. What the question wants, though, is the coterminal angle between 0 and 2 pi. So we need to add another 8 pi over 4. And when we add another 8 pi over 4, that gives us 3 pi over 4 as our angle. So, which is between 0 and 2 pi. So 3 pi over 4 is the coterminal angle this one wanted. Now, to graph this, 0 is on the right, pi is on the left. 4 pi over 4, because we have a denominator of 4. Then halfway would be 2 pi over 4. That 2 is what we'll count by in the numerator. 2, 4, 6 pi over 4, and 8 pi over 4. And now our angle, 3 pi over 4, will start at 0. And we will rotate around to 3 pi over 4. It's going to be between 2 and 4. So it's going to be halfway in quadrant 1. And there is 3 pi over 4. I meant quadrant 2. So these are your coterminal angles in terms of radians. Now, let's look at reference angles. Reference angles are positive, right or acute angles. So a reference angle must be between 0 and pi over 2. Okay? And the reference angle goes to the x-axis. So let's look at how this works. If we look at A, we have pi over 4. With that denominator of 4, 0 on the right, 4 pi over 4 on the left. Half of that 4 is 2. 2 pi over 4 to 4 pi over 4 to 6 pi over 4 to 8 pi over 4. And then pi over 4 starts at 0, halfway between in quadrant 1, pi over 4. Okay? Now, the reference angle always goes to the x-axis. From wherever our angle terminated to the x-axis is our reference angle. So, that reference angle is pi over 4, because from 0 to 1 pi over 4, that is a measurement of pi over 4. Reference angles are still how far away is the angle from the x-axis. So, in general, top of the next page, in quadrant 1, The reference angle is equal to the standard angle. Reference angle is equal to the standard angle in quadrant 1. Now, let's look at B. 5 pi over 6. Let's number this axis in terms of pi over 6, 0. On the right, left will be 6 pi over 6. Half of 6 is 3, so halfway is 3 pi over 6. Counting up, 6 pi over 6, 9 pi over 6, and 12 pi over 6, which does reduce to 2 pi. Now, 5 pi over 6 is between 3 pi over 6 and 6 pi over 6. So we're in quadrant 2. We are a little closer to 6 pi over 6. So we start at 0 and we rotate around to 5 pi over 6. Okay, our standard angle is here. The question wanted the reference angle. Reference angles always go to the x-axis, so that reference angle would go from 5 pi over 6 to 6 pi over 6. So that reference angle is pi over 6. Now, mathematically, we subtracted, that looks bad, we subtracted 6 pi over 6 minus 5 pi over 6. 6 pi over 6 is equivalent to pi. So in quadrant 2, top of the next page, in quadrant 2, we did pi minus that theta standard. Pi minus theta standard gives us that reference angle. So in quadrant 2, we subtract pi over 2, pi minus the reference angle, standard angle, pi minus standard angle. Or look at how far away it is from the x-axis. Let's go to C. We have 4 pi over 3. So we'll number this axis based on a denominator of 3. 0's on the right. 3 pi over 3 on the left. Feels weird. Half of 3 is 1.5. 1.5 pi over 3. 3 pi over 3. 4.5 pi over 3. And then to 6 pi over 3. So we'll start at 0. 4 pi over 3 is between 3 pi over 3 and 4.5 pi over 3. So we are in quadrant 3. It's closer to 4.5 than 3. So 4 pi over 3 falls here. And our standard angle wraps around like this. We want the reference angle. The reference angle is always to the x-axis. So it's only this piece of the angle. And to get that, we go from 4 pi over 3 to 3 pi over 3. And so that reference angle is pi over 3. Mathematically, we take that 4 pi over 3 because it's past pi, and we subtract pi. So, top of the next page in quadrant 3, that reference angle is theta standard minus pi. Now, let's do D. 11 pi over 6. So we'll number the axis in terms of pi over 6. Here's 0. Here's 6 pi over 6 on the left. Half of 6 is 3. So 3 pi over 6 to 6 pi over 6. 9 pi over 6. 12 pi over 6. Okay. Our angle will start at 0. And we'll rotate around. 11 pi over 6 will be between 9 pi over 6 and 12 pi over 6. It'll be closer to the 12 than the 9. So 11 pi over 6 is here. That standard angle wraps all the way around, but our reference angle only goes to the x-axis. So this is our reference angle. From 11 pi over 6 to 12 pi over 6, that reference angle is pi over 6. Mathematically subtracting, we need to start with 2 pi because in quadrant 4, that's where the closest x-axis falls. So in quadrant 4, that reference angle is 2 pi minus theta standard. Okay, those are the formal formulas. You don't necessarily have to use them that way, but you can. Okay, now, if you look at all of these angles, if you look at all of the standard angles versus their reference angles, pi over 4 stayed pi over 4. 5 pi over 6 became 1 pi over 6. 4 pi over 3 became pi over 3. 11 pi over 6 became pi over 6. So the reference angle is pi over whatever your denominator was. No matter what the denominator started out at, the reference angle will be pi over that denominator. So reference angles in radians actually turn out to be pretty simple. Whatever the denominator is, pi over that denominator is your reference angle. So let's take a look at one more quick thing on this part of the video. If we look at the unit circle and we just label it in terms of pi, 0 on the right, pi on the left, pi over 2 on top, 3 pi over 2 on bottom, equivalent to 2 pi on the right. If we're looking at those quadrantal angles, those angles that are on an axis, if we look at 0 degrees, its reference angle is going to be 0 degrees. Same thing in radians. 0 radians, that reference angle is 0. If we go to pi over 2, that reference angle to the x-axis is pi over 2. That reference angle is pi over 2. If we look at pi is on the x-axis, so its reference angle is 0. It doesn't move. Our angle doesn't move from the x-axis, doesn't move from 0. So its reference angle is 0. And if we look at 3 pi over 2, that reference angle to the x-axis is pi over 2. So in general, when we have an angle that's on a quadrant, our choices for reference angles are either 0 or pi over 2. We are either on the x-axis, so 0 degrees away from it, or we're straight up or straight down, which is pi over 2 units away from the x-axis. Okay, I'm going to stop this part of the video here. There will be another part with the rest of these examples. See y'all.